Hello and happy Monday. Today we're going to be taking a pause from distance for most of the video to think about area, because that's where we're moving with circles. But first, a note on the practice check, because that was about distance. So we're thinking about the relationship of diameter, radius, and circumference. To remind ourselves, and it's always good to have that visual for yourself, we have the radius, which means that then the diameter goes all the way across, and the circumference is the distance around the circle. So we have two circles, a circle A with a diameter of 9 centimeters and a circle B with a radius of 5. So when we have a diameter of 9 centimeters, and we're going to leave that as is for now. When we have a radius of 5 centimeters, if we want to get the diameter, that would be 5 and 5. We could go times 2 to get that the diameter is 10 centimeters. So I already, looking at this, knowing that 9 compared to 10, I already am going to conjecture that circle B is going to have the larger circumference because it has a larger diameter. But let's be sure. Their circumference now would be if I multiplied by, let's do 3.14 to be a little bit more precise. And if I do 9 times 3.14, I'm going to get that the circumference is approximately 28.26 centimeters. And now here, when I do 10 times 3.14 for the circumference, that's going to be approximately 31.4 centimeters. So I was right. The larger diameter also yields a larger circumference. So circle B. And how many centimeters larger? I can do 31.4 centimeters minus 28.26 centimeters. Well, let's see, if we have 31 minus 28, 3.14 centimeters. Ooh, so in fact, approximately 1 pi more, which makes sense because this is a diameter that's 1 greater, so when you multiply it by pi, it will be about pi greater. Cool. So now, thinking about area. We paused on circles for a moment so that we can focus on what it means to be larger. And we talked about a larger circumference in the practice check, but here I want to think about a larger shape overall and what that could mean in terms of area, or how much space, how many squares a shape covers. So we've got these 3 shapes. We have these 3 classroom blueprints. I'm trying to think which is going to make the largest room. Looking at this, I want to figure out how many squares does each of them cover. And just looking at them, they're kind of funky shapes. It's hard to say immediately which one's bigger. People had a couple different strategies that I'd like to highlight. One strategy was what we're going to call boxing. And they boxed in the entire shape because then they could find the area of the whole rectangle, and then they had to take away any of these extra pieces. So through the boxing method, we would go, well, this was 5 and 5. We have a width of 10 and 5, 5 and 5 by 15. So we would have an area of 150, and then we would need to subtract out all of this extra. So that's one way to do it. Another way is by decomposing the shape, cutting it down. And if you decompose this shape, there are a lot of different ways you can do it, but everyone that I saw decomposing, they were thinking about how they could break it into shapes that they could find the area of more easily. And that ended up yielding triangles and rectangles. And some people did it by taking this entire area and then this entire area and then 2 triangles. Some people chose to break the triangles up more. Some people even broke up that rectangle into 2 squares. But however you do it, it's going to end up yielding the same area because you've just broken it up in a different way. You haven't actually changed that shape. So if we're looking at this, we've got 5 by 5, which is going to be 25 square units, and another square that is the same, so another 25 square units. And then here, we took a 25 unit square and cut it in half. So this would be half of 25, or 12 and a half, and then down here it's the same. So we have 12.5 units squared and another 12 and a half units squared. Together, those would actually combine to make 25. So you could always pull that one down to make a rectangle there. And then that just leaves us this piece right here, which now we see that boxing in that triangle is useful because we have 2 by 5, which tells us that the area of the whole rectangle would be 2 times 5, or 10, but this is only half of the rectangle, so this would have an area of 5 units squared. 25, 25, 25, and 5, the entire area is going to be 80 square units. So things that we've found. The area of a rectangle is helpful if you're thinking about length times width. And the area of a triangle, you could box it into a rectangle, which you know is going to have an area of length times width, and then you have to divide by 2 to get down to that triangle. Let's apply that here. Except this time I'm going to use the boxing method because making a box appears to be very simple here. I have a 10 by 10, which would be 10 times 10, 100 squares. And I'm going to take away, this is half of one of those 25s and another half. So I'm going to take away 25 because 12.5, 12.5, this is going to be 75 squares. Another way people noticed this one was that if you pulled this over, we're going to have 25, 25, 25, 3 large squares, which would be 75 squares overall. And then for this one, I'm going to choose to dissect. I have 1, 2, 3, 4, 5, 6, 7, 8. 8 by 8, so that's a 64 squares. And then I have a triangle that is 8 by 1, 2, 3, 4, 5. Box it in. I'm going to end up with a 40. Area of a triangle, 40 divided by 2, it's going to be 20. So this would be 84 squares. So the largest is Miss Angel's, the smallest is Mr. Peters, and the difference would be 84 minus 75, which would be 9 squares. Okay, strategies then. 2 major strategies if we're thinking about counting up squares and getting to a place where you don't have to count every whole and partial square and can instead start looking at length and width. One is decomposition, which people were naming making shapes. Another would be boxing. So when you decompose, you have something that looks like this. You cut the shape into easier shapes. Usually we're going to make rectangles and triangles. We know how to find the area of each of those, and then you add them together to get your whole shape. The boxing method, on the other hand, you would want to take this, box it in so you have a whole rectangle. We can do length times width. And then to get down to the triangle, we know we would need to do times 1/2, or divided by 2. And we need to take out, subtract anything that's extra. To apply that here, we have a funky heptagon, 7-sided figure named Destiny. And in this funky heptagon, people found a lot of different ways to break it up. Some people chose to break it up this way. You can really break it up as small as you want. I'm going to go with this, but there are other ways that you can do it. So I have a 5 by 5. So I have 25 squares, another 25 squares. Ooh, these are those half, so I could pull those 2 together to make 25 squares. I have 25 squares. Let's see, this is 10 by 5, 10 by 8. So if I box this in, I would have 80, but I need to divide by 2 because I only have half of it. So this would be 40 squares. And then here, going down, we have 5 across by 3, so 15. If we box that in, 15 divided by 2 would be 7.5 squares. Altogether, I have 25 times 4, 1, 2, 3, 4, which is 100, plus 40, plus 7.5. I'm going to have 147.5 squares. 147.5 square units that are covered by that shape destiny. Tomorrow when we get to circles, we're going to think about how can we apply finding the area of funky polygons to finding the area of something that curves. Have a great night.